welcome. I'm Julien. I'm the author of this book, Vertex in Action. And today in this Twitch session, so I'm very happy to have you all here. First off, can you? So I'm looking at the chat actually. This session is not going to be like a talk in a conference. It's going to be more like live coding and showing you some Vertex, some Reactive, and also I'll be monitoring the chat to see if you have questions. And by the end of the hour, I'd like to have some kind of free-form Q&A. So please, if you have any questions, just drop a comment. I will have a look and I will try to answer you. So it's a bit unusual not to have people face-to-face or hearing your feedback, but I'll do my best. So what we are going to do today is pretty similar to what you can find in the book, although it's not exactly the same thing. So what we will go through today, it's actually four things. So the first thing we're going to use is we're going to have a look at the Vertex core APIs, especially what we call verticals and the Eventbus. And we will be building a very simple HTTP API. Second thing we're going to do is look at some SQL client for PostgreSQL. Then we'll do some kind of edge service. So we will play with a HTTP client to make requests to other services. And here we'll do some chaos engineering, which is extremely fun because you can just break everything and see what happens. So basically what we'll do, we'll just introduce some delays in the SQL database, and we'll see what happens and how to mitigate issues. And if time permits, we'll look into real-time web applications. So let me just show you what we are going to do in the first step. So what we're going to use a very simple running example through the hour. So what we will have is temperature sensors. So they're not going to be real sensors, of course, because I don't have sensors with here. But you could the code would not be very different from what you would have if you had some real sensor talking over, I don't know, MQTT, HTTP, Kafka, MQP, whatever. So the idea is to have these simple sensors. So each of them is going to be a microservice. It's going to expose an HTTP interface, a very simple API we will be able to get data from. And whenever they update the temperature, they will push an event to what we call the Eventbus. And we will see what happens. In a second step, we'll have another microservice, which is here, which is going to look for all temperature updates and store this into a Postgres database. And it will also expose some queries over some HTTP API. The third step, we're going to have some gateway/edge service, which is going to give us a simple API to get all the latest data or some very specific data. So it's going to look for updates and maybe sometimes query the store services. And the last step, we'll have some kind of dashboard, which is a web application, and it will receive live events from the whole system. So we'll have a live interface, and I will show you how to do it nicely with Vertex. So if it sounds good, let's start with this, which is making sensors. So I'm going to use IntelliJ, but you can just whatever you want you can use Visual Studio Code whatever you want. So if we want to have a sensor, we need a class to represent what's in a sensor. So in Vertex, in the core APIs, you have two concepts to understand. One is the verticals and the other is the Eventbus. So a vertical is where you will put your code. The whole business logic is going to be into verticals. And verticals is the basic deployment and code unit you will have to deploy. It's as simple as that. So if you want to have a sensor vertical, well, you have a sensor vertical. And what you have, all you have to do to make it a vertical is to extend something called abstract vertical, which is part of the core APIs of Vertex. So what we will need to do a sensor, first thing, we need some kind of identifier. So the UUID is really fine. So we just generate that. We're going to have a temperature, which is a double. So this double is going to evolve over time, and we will see how to do that. And to make it change, we'll have a random number generator. As simple as that. Of course, we need to log events because it's very convenient to log and see what happens. And the last thing is we will need some HTTP port to run the server. So to do that, we will just use environment variables. So in our case, it's going to be HTTP port, and by default, it's going to be on port 8080. But it's something we can override if you want to. So that's really the skeleton of my vertical. And the vertical is a very simple thing. It doesn't have many methods. Basically, what you need to override is the start method. Maybe the stop method in some cases if you want to do some cleanup work when you shut down a vertical, but in practice it's really the start method which you're going to have to override. Stop, yeah, it happens, but not that frequently. So when you have this stop method, when the vertical is going to be started, you can see here we have an argument which is a promise. So this is because we are using Vertex, and in Vertex everything is asynchronous. So we are going to deal with lots of asynchronous things, and because starting the vertical is going to be made out of asynchronous operations, we need a promise, which is an object we will complete to say whether we actually succeeded in deploying the vertical or if we failed. So what I mean by that is that this vertical is going to start an HTTP server, and because you start an HTTP server, you need to report if you manage to start the server or if you failed. And basically the reason is very simple. You may not be able to start a server. For example, if you start below, if you use a port number which is too low, basically you're going to fail because you may not have the permission, or maybe the port you want to open is already in use. So in those cases you will fail. So how does it work? So let's start by just updating the temperature. So when you're in a vertical, you have an object which is called Vert.x, which is a field. And from here, you have lots of basic operations. So for example, I can create an HTTP server. I can access the Eventbus, which is something we will have a look a bit later. We can deploy verticals. We can have periodic operations. We can close the Vertex context. We can have datagram sockets as server, as client. We can make the DNS client because we may want to make queries. We may have a HTTP client. We have a TCP client, etc., etc. So basically, you have all these low-level methods to create all kind of networked applications with Vertex. So if you want to update the temperature, what we need to do is to have a method, a callback, which is going to be called, say, every 2 seconds. So every 2000 milliseconds, we're going to do something like this: update temperature. Okay, so this is going to be called every 2 seconds, and from here we're going to update the temperature by some random number. So the long parameter which is given here is just the identifier of the periodic timer. In my case, I just don't care, but you may be interested if you want to cancel this periodic timer, basically. So what I'm going to do here is I'm going to say temperature equals temperature plus I'm going to use next Gaussian from my random number generator, and I'm going to divide that by 2. That's it. So next Gaussian is going to give me a number between -1 and +1, and I'm going to divide by 2. So this is going to be a very simple model to update the temperature. So I'm going to do this, and I'm going to log this to say temperature updated, and I'm going to give the new value, and I'm going to do temperature like this. So if I want to run this, so I'm not even creating an HTTP server or anything. So I have my periodic task which is being set up, and I want to say that my vertical is working. I'm just going to say complete on the promise to say, okay, I'm done. My setup is done. My vertical should be working. So here we go. So we'll come back to adding an HTTP server and HTTP API, but first let's just try to deploy this vertical and make it work. So in Vertex, you don't need anything like you don't need an application server, or you don't need this kind of thing. You can just have a main method, and it's a very simple programming model. You have a main method, you deploy your vertical, and that's it. So what I'm going to do here is create a Vertex object like this. In this Vertex object, I'm going to say I want to deploy a vertical. So you can pass a name, you can pass an instance, you can pass a class, you can pass many things. Something you can do is, so what's the name again? It's sensor vertical. You can say sensor vertical new, like this, and this is going to pass a supplier. And what's wrong with this? So I've made a mistake, and I don't know why. So I'm going to do something very simple. New sensor vertical. Okay. So I'm just going to deploy it like this and run. So yeah, and this is it. So you can see that every 2 seconds, my temperature is being updated. And so I'm going to start the application and show you one thing from the logs. You can see here that the thread identifier in logs is going to be the same for every invocation. So this is called the event loop thread 0. If I had deployed another instance, it would be another thread. So basically what I can do is I can show you what happens if I deploy this multiple times. So it's sensor vertical, and you can pass deployment options to say I want, say, 4 instances like this. So if you do that, you will deploy 4 instances of this vertical. And what's going to be different here is that you see that I'm stopping it again. You can see that we have different threads because we have 4 instances. We have 4 threads operating. So one thing you need to know is that a vertical is deployed to exactly 1 thread, which is an event loop, which is processing asynchronous events. And it's something you should not be blocking. You should not do some blocking operations while you're running on the event loop. So that's a very simple example. I'm going back to this and have an HTTP API. So what we need here now is, so we need to create an HTTP server. So there is a nice router object you can use. So a router is an object to define your HTTP endpoints based on path and methods, etc. So you can define a router like this. You can say that when you get a request on a HTTP GET request on /data, then you define a handler. So the handler is going to be called to process the HTTP request. So we can call this get data, for example. We're going to create this method. with context. More to that in a minute. And yeah, I think that's it for this method. So what we need to do now is create the HTTP server. So we create the HTTP server. We say that all requests are going to be handled by the router, which is then going to dispatch the request to handlers. We say that we want to listen on port, the HTTP port, which is given as an environment variable, and this gives us a future. So this future object is to notify us whether the operation, which is here starting the HTTP server, succeeded or whether it failed. So do not confuse the Vertex future with those from the JDK. They are much more complete in Vertex and they are non-blocking, which is not the case of those from the JDK. So first thing is we're going to say, so in case of success, so when we manage to start the HTTP server, we're going to say, so we have a callback here. On failure, because you have some kind of failure, well, we say start promise fail. So by doing this, you will just propagate the failure down to the class that's been deploying. So we are going to say HTTP server running. So we are going to repeat some stuff in the logs, like the HTTP port. Okay, and once we have that, we can do start promise.complete to say that the operation succeeded. And we need to actually implement that. So when get data is called, we need to answer the HTTP request and give basically the temperature data that we have. So what we have to do is prepare some kind of Json object, which we call payload, or just call it whatever is fine to you. In this object, we are going to, so this is a Json object is from Vertex. It's a class we have. So here we are going to say, so the ID, just checking something, was being expected from the other side. Yeah, it's UUID, not ID. So UUID, we just put our UUID. These are current methods, so you can just change things. Temperature, we pass the temperature, and we put, last thing, we put a timestamp because it's very important, and we just use system current time milliseconds. It's not too bad. And then we go through the context. So we say context.response. So we need to say that it's going to be JSON. So we say content type. So we had we need to add this header to say this is application JSON content. And yeah, basically we just needed to end it with the string. So we take our payload and we say encode. So there are two encode methods to encode JSON to text. So encode is the compact form, which is as a one-line string. But sometimes when you want to debug, there is also encode prettily, which is going to give you a nicely formatted JSON object. So we just encode. Something we can also set the status to 200 to say the request was fine. We may also log to say that we've been processing a request from, so processing HTTP query or request from, and we are going to give the requester. So we go context.request remote address, and this is going to tell us who's been making the request. So if I do this and I run my application, if I run this, should work. So let me check. So my temperature is being updated. Great. My server is running, etc. So everything is happening on one thread again. So I'm using port HT80, sorry, and it's data, and it works. So I'm making a query, and I'm getting my JSON object. It's very simple. And if you look into the logs, what we can see here is that, again, there is only one thread that's been managing the periodic task to update the temperature and also serve the HTTP request. So the threading model in Vertex is very simple. Once you deploy a vertical, it's running on just one thread. It's going to be an event loop thread, and it's going to be the same for the whole life of the vertical. Yeah, by the way, if you have any question, just drop something in the comments, and I'll do my best to respond. So that's how you can do a very simple microservice. Something which has been specified because the next step will be to have a store like this or this way. So we have a store, so we want some service to be able to notify, to receive all the updates. So this means that my sensor service needs to publish the temperature updates to something called the Eventbus. So let me show you how to do this. So I'm going to go back here, and in my update temperature methods, I'm going to publish this. So I'm going to reuse this actually, creating the HTTP, well, the JSON payload. So I'm going to have a method called create payload like this. And I'm going to go through the Eventbus. So I go through the Eventbus and I say publish to some destination, which is a very simple string. So I'm going to say it's temperature.updates. I publish some JSON, which is my update, and this is going to be sent over the Eventbus. So when you do this, I can show you how it works. So for example, I'm going to my main method. I'm going to do something you would not do in practice, but I'm still going to do it just to show you how it works. So the Eventbus is really what you should be using to make your verticals communicate with ephemeral events. So you can have a consumer that's going to listen to temperature updates, and is going to receive a message, and that message it has an address, a body, and headers which you can define. So it's a very simple, lightweight kind of not messaging but eventing system. And whenever there is an update, what you can do is log from here. So it's going to be logged from the main method, and I'm going to do something not really nice, but like this, and message the body, and I'm going to I just need to say it's Json Object because it's going to be some JSON. So and encode prettily, so in the logs it should be nice. And this way, so my vertical and my main method, they should be communicating like this. So as you can see, from the main method, I'm using another event loop. So the vertical is on one event loop, and the main method is creating some kind of hidden context under the hood for you, just to stay faithful to the Vertex threading semantics. But you receive this update over the Eventbus. So that's one part of the equation. The thing is, the Eventbus like this, it's working just inside your process. It's not working across the network. And it's exactly what we need to achieve in this step. So in this step, we need the Eventbus to work across the machine. So there is a mode called the clustered Eventbus. So we can have a Vertex instance, but working as a cluster. And in this case, the Eventbus is not just working inside your process to dispatch events, but it's also working across a distributed system with as many nodes as you want. Well, as many, it depends. Of course, if you have 30K instances of our network, I'm not sure it works fine, but yeah, you get the idea. So if you want to use the clustered Eventbus, the only thing you have to change is here. It's here. So when you want to deploy, so you do, you say, I want a Vertex clustered Vertex with some options. So in these options, there's a whole bunch of things you can customize, but for today, you don't need to customize anything. And basically, so yeah, the clustered Vertex instance is not going to start straight away. It needs to connect to the cluster and set up the cluster manager, etc. So it's an asynchronous operation. And again, we can use the future to say, to have our Vertex instance on success. And on failure, yeah, we have a failure. We can't connect to anything. So in this case, we may just log and say error because whoops. So I'm not trying to be too creative in the names, as you can see. And here we're going to deploy vertical, and we deploy sensor vertical, and that should be fine. So if I run this like this, it's going to run with clustering. So with clustering, you have a bunch of cluster managers. By default, we recommend Hazelcast because it's fine. There is InfiniSpan as well with JGroups. You can use Consul with a module from community. You can use Apache Ignite. So we have different engines that you can use. But the idea, so I'm going to shut this down and switch to the terminal to show you how it works. So I'm just going to package my just try to compile to have some jars and run stuff because I'm going to run 4 sensors from the command line. So I have something called run sensor on port 8080 like this. So when it starts, you have a bunch of logs from mostly Hazelcast, and here it's telling you that there is only one node in the cluster right now. But if I start another on port 8081, so it's going to start another port, but in the logs, we should see that so we see that in the cluster, we now have 2 members here. And if I create, not like this, like this, like this. So if I run 82 and 83, we have 4 sensors running, and they are dispatching their temperature updates to whoever wants to listen on the Eventbus. But it's not too bad. I'm going just to do something in advance to show you how it works. I'm going to run the dashboard just to show you that we have live updates. And then later on, I will show you how it works. So it's HTTP, I think it's on port 5000. Yeah. So we have here our four sensors, and we have the live updates. So it's all running with the dashboard in real time. So yeah, the point here is just to show you that just by putting Vertex in cluster mode, I have all my nodes sending events to whoever is interested. So I'm going to shut this down because the goal was not to show you this straight away. And we're going to switch to the next step. So having Postgres as a service to store events. So it's going to listen to all these updates and store that into a database. So how it works, I'm going to switch to, so we can just forget this project. We go to temperature store, and it's using a Postgres reactive client from the Vertex project. So it's a clean implementation based on the wire protocol of PostgreSQL. So it's not JDBC, it's really non-blocking code that we give from the Vertex project. And the performance is really, really good. So to connect there, so it's more or less the same canvas for the vertical. We are going to run on HTTP port 7K. And when we want to connect to Postgres, we are going to use a class called pgpool. So pgpool is the pool of connections to our database. You need to pass some options, like obviously what's the host of the database, your credentials, the database, etc. So in my case, it's all hard-coded it's in the code, and I'm not showing you the good thing, sorry. Yeah, this way. Still new to this OBS thing. So you create this pgpool object, and then you have your host, user, database, password, credentials, etc. So here, this is all hard-coded, which is bad, of course. IntelliJ. So yeah, this is bad, but of course, it's something you can override with environment variables, file configurations, files, etc. So I'm just putting this hard-coded in this example because it's just very easy to understand. So what you need to do is, so to receive the updates, you just listen over the Eventbus to temperature updates. And whenever you get an update, you will just call this method, which is going to make an insert into the database. Then I have some HTTP API because I want to either fetch all the database or I want to fetch only the data for a given sensor, or I just want whole data but over the last 5 minutes. So these are the different routes I've defined for this service. And yeah, to show you, we are going to do this implementation. So get all data. So get all data. First, I need to show you the schema. So I'm not using any object relational mapping tool or anything. It's just plain SQL and PostgreSQL. So the schema is pretty simple. We have the UID, the timestamp, the value of the temperature update, and the primary key is a combination of UID, and timestamp. It's pretty straightforward SQL. So if we get there, so the query we need to do is select everything from temperature records. So we need to go with pgpool, have a query, a prepared query. So we do like this, and then we need to execute. So you can pass a tuple. A tuple is one you want to pass values. I'll show you that in another query. So I'm going to execute, and when I execute, again, it's an asynchronous operation because you need to talk to the database, fetch the results, and get back to you. So we have a future, and I'm going to say on success. So I have a row set, which is a bunch of rows. So in this case, I'm going to do something, and on failure, I'm going to I'm going to do something else. So I will start with the failure. So I want to get all data. I want to so if I have a failure, I need to basically say everything's gone wrong. So you go through the context, you just fail it like this, say 500. So this is HTTP 500 to say, boom, I'm just dead. And of course, what you should be doing on the server side, you should be logging. So say, whoops. So I don't have time to be fancy with the log message. And I just wrap up the failure. So what's more interesting is what happens when we actually have the rows. So we can do something like for row in rows, and we're going to do something. So what we need to do is assemble all the values into some kind of big JSON document. So for that, we can have a JSON array like this. So it's a JSON array. For each row, what we need to do is array.append to add. So we add a new JSON object. And this JSON object is going to be made out of the values from the row. So we need to say UUID, comma, what am I doing? Put, so we put U like this, UID. So row dot get value, get, it's a string, so we can say get string UID like this. We need to repeat, so I don't remember the schema, it's the value. Okay, so we need to put temperature and row dot get double value, yeah, value. And we need to repeat the, what am I doing? And we need to repeat the, yeah, like this. Boop, 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 something wrong. Put timestamp like this, and it's going to be get temporal, I think, and it's tstamp. So tstamp, I'm going to go to string because otherwise it's not going to work. So let me check, because I'm lost with all the parents and stuff. Okay, so I'm adding every row to the array, and then, yeah, then I should be fine. So I can just go to context, dot response. So we need to say that this is JSON. Let's put header. So we say content type, it's gonna be JSON. And we end with, so we create a new JSON object just to wrap the array into an object, which is a quite common pattern if you do some JSON. So we say data, and we pass array, and we encode, and we should be good. Yeah. So does it work? So let's try. So again, it's Vertex code is very simple to run. You can just use a main method and run from your IDE. It's just fine. We're just waiting a few seconds to see in the logs that we've joined the cluster. So yeah, connection refused, of course, because I didn't start the Postgres server. So yeah. So to start the server, I'm using Docker Compose. It's very simple. I don't have to remember the whole Docker command line thing, which is big, not to say anything else. And I'm going to start again my service. So to join the cluster, you should see all the members, which are the sensors plus this new service. Okay, so this is deployed, and you can see in the logs that we are recording a few values. That's fine. And then if I make a query, so it should be HTTP. I don't remember the port. So what's the default port? The default port for my service, it should be 7K. Okay. So 7K, and I don't remember. It's all okay. Very simple. Yeah. and you get all the data from database. So again, this is running from a single event loop for the vertical, and that's pretty fine. There are some other things you can do, like for UUID. So if you want to have a variable path, a variable in your path, you can do it this way with this syntax. So it works it's pretty similar. So you do another kind of SQL query, and here you can see that you have a parameter, which is here $1. So it's going to be the UUID of the sensor you'd like to get all the data from. To pass this as an argument, you wrap it with execute inside the tuple, and there you go. And then it's pretty much the same logic you have. If you want to get the last 5 minutes, again, it's from the Vertex side, is exactly the same logic. You make your query, and then you had the HTTP response. Then it's just, get back to school, do SQL, pretty simple. And the thing I should be showing you, which I haven't, is what happens when we receive an event. So we just do same thing here. We just do an insert into the database, and we just store the data we receive from the Eventbus in JSON, and we store that onto the Eventbus. Does that make sense for you? Do you have any question? I'm not seeing any question. Yeah. Oh, yeah. Somebody said in the chat, get back to school or buy the book. Yeah, I can recommend you this book. It's not too bad. So what we can do, then we do some chaos engineering. But before that, I will show you Edge service. So how to use an HTTP client. So the goal here, so we have our sensors. Oops. There. No, I'm not sure. Yeah, this way. So we have our sensors. We have the store service, and now we need some kind of gateway / edge service to make a simple HTTP API to connect to all these all these things. Before I go ahead, so there is a question where the tuple class comes from. The tuple class is from the Vertex SQL client. So it's simply something we have in the Vertex APIs for the SQL clients. So it's not a tuple from some other libraries. Another question, can you use an object relational mapper? It's not, well, in theory you could. I would recommend, if you really need something which is not plain SQL, I would recommend you use something called Juke, and there is a binding called Vertex Juke in the community that you can find. Other than that, it's actually refreshingly simple to do SQL. Believe me or not, it's actually very simple. So if I go back to coding, so yeah, when I said maybe you don't need an object relational mapper, it's not intuitive, but yeah, sometimes simple is better. So we have our edge service. So the edge service is that gateway style of service. So I'm going to rush through this thing because I'm being very talkative today. So I'm going to try to, yeah. Going to try to go back to what's the, no, not this one. Okay, so we need to do it very quickly. So what's different here is that we have something called the web client. So the web client is a nice usable HTTP client if you want to make queries to other services. And the idea in that kind of gateway service is that if you do /latest, you will just push back the latest temperatures you've been observing, and you've been observing and caching them in a very simple hash map. And a hash map works again because there is no race condition concurrency thing going on. So you just you can just use, because you're always going to access it from the same thread. You don't need to do anything. You don't need to synchronize use logs, etc. So if we want to get the last 5 minutes from the gateway, we need to talk to the store service. So what you need to do here is use the web client and do a get. So you can do, get, delete, post, whatever HTTP method you want. So you need to talk to the, have an environment variable for that. Store host, okay. So store port, store host, and I don't remember what's the URL. So in this service, it's last 5 minutes. So you need to make this query to the other service. So last 5 minutes. So what's nice with this API is that you can say that you want the response to be decoded for you, like as a buffer, JSON array, text, whatever. So you can just say JSON object. So you say, give me a JSON object because it's much nicer for me. What else? You just send and you have a future. So it's going to give us an HTTP response. So I'm going to do something like map to say request.body because it's JSON. I just want to map so that I can extract it. And I have my JSON, which is great. So when I have my JSON, cool, on failure, I'm going to simply say failure and context fail 500. So again, I should be logging, etc., but we don't have much time, so I will just do something a bit simpler. So I have my JSON, which is from the other service. So I need to use my context, go through the response. Just say again that this is going to be some JSON. And end with JSON.encode and should be okay. And status 200. Although you have it by default, it's a bit better to do it. It should work. So I'm just going to quickly recompile. So I have my Postgres database running. Compilation should work. Hope so. Yeah. So if I go to the Edge service, I'm going to run the Edge service. So it should be, yeah. Whoops, should work. So I hope it works like this. Just waiting for it to start. So it's a bit longer to start because we are using clustered Eventbus. If you don't use clustering, it just starts in a snap with Vertex. So if I do this query and I want, so what's the endpoint? It's latest. Okay, so let's see latest. So this is the latest data from the Eventbus, and the other one is 5 minutes. So if I do 5-minutes, boom, I have an error. Cool. This is the beauty of doing things on the go like this. Where did it go wrong? Ooh. So for some reason, there is a failure, and there is no good demo without a failure. So I've made something stupid, I'm sure. And of course, I'm not logging anything, so I can't find it. So let me go back to the Edge main method. Should be this one. Okay, so I need to expand this and log. Okay, so I'm going to kill the version which is running here. I'm going to run from here. So maybe I'm just wrong with the port numbers or something. Okay, so this is starting, blah, 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 6K. So can I see anything? Whoops. And connection refused. Okay, so I think I'm not on the correct. Oh, of course. So it's not running. So yeah. So I must run the store on port. What is it? 6K. Ah no, it's 7K. I'm wrong. 7K. Sorry for that, people. Yeah, wrong endpoint. Yeah, you're right. So this works. The edge in my here should be working, and then yes, it works. So I'm making so yeah, I've been able to do this. Yeah, Thierry, it's all good. So I have this working. I'm just going to launch it from not from my IDE, but from the command line, because now we are going to do some chaos engineering, which is great. So don't cry, Thierry, we're going to break everything. So just running the edge service. So I have my 4 sensors, my store, and my edge service. They are running. I'm just going to check if I can get, yeah, so everything is running. And I'm going to use a tool called Hey. And I'm going to do this query like last 5 minutes. Is it the good one actually? 5 minutes like this, yeah. So I'm going to use Hey, and Hey is a very simple tool to do some load testing. So by default, it's doing 200 requests, and we have this distribution of response times. So it's basically the latency. So it's the time when you are talking to the edge service, and the edge service talks to the store service, and the store service talks to the database. So of course, you need to warm up the application, etc. But you know, it's working. So I can see in the chat that somebody is waiting for proper chaos. So you can see that all my responses are pretty okay. We are below. Yeah, we're pretty good. So what I'm going to use is a tool called Pumbaa. And I'm actually not going to kill the database. I'm just going to introduce some delays over the network of the database to the service. It's pretty simple. So all the network requests that go through to the Postgres database, they are going to be delayed by. So for 1 minute, they are going to be delayed by 3 seconds plus minus 5, 0.5 seconds. So I'm going to do this. PG chaos like this, and we got some delays. So my database is still working, but now if I make a query, so I'm going to do it manually like this, and we just got to wait for, you know, some time. So HP 3 plus, I don't know, seconds. So we're waiting, we've got some delays, and everything is down. And if you run Hey like this, it's going to be worse because it's going to be a nightmare of delay. So with Vertex, we've been using asynchronous things. It's been great, it's been fast, etc. But all of a sudden, everything is going down because we have delays. So basically, my system here is not responsive. It's just, you know, stuck because of network delays. So yeah, I'm going to let Hey run in the background. But what we need to do now is mitigate this kind of failure. So if you want to mitigate this, because I don't have much time, I'm going to use some Git magic and get back to the version that was working properly. So just to show you what Hey had. So just by introducing natural delays, we had this kind of histogram. So yeah, the response time is going to the roof. And it's not been too bad here because we were near the end of the chaos period, but yeah, it should be worse than that. If we've been running Hey differently, it would be much worse. So if you want to avoid that and have a service which is still responding, even if you have a failure on the database side or any other service side, you need to use something called a circuit breaker. So a circuit breaker is a very simple kind of proxy between you and something else when you want to do an asynchronous operation. And when you start to see enough failures, so you have a threshold that you can set. Once you start to see failures, the circuit breaker is going to be open to say it's not worth sending request because the system appears to be down. So the circuit breaker is going to be open and we can just respond with some default values. And after some time, the circuit breaker is going to be half open, so it's going to try to reconnect. And if the next request succeeds, we get back to the closed state. So the circuit breaker says it's okay, you can make your request. And if it fails, well, you just go back to being open to make sure you're not trying to overload a system which is broken anyway. So it works like this. So you have your circuit breaker, you give it a name, as simple as that. And then when you want to make the web client query like this, so this is more or less what we did manually. And we are doing two things. So one thing is I'm adding a timeout on the HTTP queries to say that after 5 seconds, if I don't have a response, it should be an error. This is a good practice to do, because if you want to ensure bounded time on your responses, you need to set a bound. So just give a timeout, something like maybe 10 seconds, 15 seconds, depends on your system. Don't do something like 500 milliseconds because it's probably too short, but do something like this. And then you wrap the whole operation with the circuit breaker with execute. It's giving you a promise to say when you've completed the operation correctly or not. So when we get the response, in our case, when we have a success, we complete with a JSON value. So we pass, so the promise is going to complete with the JSON value if we manage to make the request. If we have a failure, we just report the failure to the circuit breaker. And then, so this is the future, and then you have your future. So on success, so you've managed to make the request. So what you do is that you cache the result. It's going to be used later on. So here you just get back to the client with a response. If you have a failure, then the good thing is that you're going to fail. So there are two options. Either you just fail, but you fail quickly, so your client is not stuck waiting for some response, which is going to happen in maybe a minute or 2 minutes, or I don't know. So you just want to fail fast. And then it depends on the application domain, but if you're managing temperatures like we do here, we don't really care about what happens with, we can just serve some old data, so we just cache it. So if we have some older data, we will serve the older data. And if not, well, we just fail, but at least in both cases, the service is still able to respond. So the difference here, so I still have my database. I'm going to introduce some chaos here. I'm going to kill the old version of the Edge service and run it again. So I have some chaos going on. I have my edge service, and I'm going to make a request. So I'm going to request the 5 minutes. And yeah, it's not what I wanted. I wanted to make, yeah, it's been fast, but it's not exactly what I wanted. So I want to show you what happens, not with load testing, but I'm just doing a request. So in this case, well, I have nothing I can give you because there is an error. And because we use the circuit breaker, then the circuit breaker is waiting. So we're gonna wait, yeah, for the circuit breaker to be half open. So it's ready to try again. If we try again, it's going to wait for 5 seconds until we get a timeout. It's going to break again. So the issue here is that we have no cached data. So here the chaos is done. So if I do this, at some point it should be open again. Open circuit. And then I have a question in the chat. Yeah. What's going on? It's half open. Okay. Yeah, and there I get some values back. So it was the time for the circuit breaker to be half open and ready to make something again. So if I run the chaos again, and I try to make that request again, it's going to wait. It's going to have some issues, but it's going to give me some cache data. So I'm going to be quite, it's going to be quite okay. And if you use hey like this, the histogram of response time is not going to be too bad. There is a question in the chat. What's the maximum number of elements in a cluster? Well, there is no strong limit, so it's a bit hard to say. But if you tell me you have 50 instances, I'm probably going to tell you it's fine. Then if you tell me you have 3000K, is probably too much. What happens is that the more nodes you have, the more traffic you have on the network, because you need, depending on the cluster manager, they're more or less chatty. Then you have the Eventbus communication. So yeah, don't go crazy, but for a reasonable number of instances, it should be fine. So yeah, you see that, just by using a circuit breaker, you're able to keep your service more or less responsive. So that's more or less what I wanted to show you. The real-time dashboard, I'm going to show it back to you just so we finish on that, and then some questions. So again, this is a dashboard. It's going to be connected to Vertex and listening to all the updates from the sensors, and it's going to be updated in real time. Here I can show you how it works. So it's actually using the Eventbus, just like we did for the other communications. So how it works is very simple. So you go to the dashboard. In the dashboard Java class we have, it's serving the HTML page from as a static file. And then there is this special thing called the sock.js handler. So sock.js, it's more or less like WebSockets, except that it's a library that can degrade to other type of connections like long polling. If you have a browser that doesn't support WebSockets, or if you are on a network with some proxy that is disabling WebSocket connection, etc., sock.js is able to, have some kind of degraded mode to handle this. And the idea with the sock.js handler is that it's going to allow the JavaScript client in the browser and the backend to communicate over the Eventbus. So it's actually extending the Eventbus to the client like this. So the dashboard service is listening to all the temperature updates and pushing that to all the connected browsers. So how you do that is, so that's on the backend, you just need to say which destinations are being permitted, because you may not want to forward all the events from the Eventbus to the JavaScript client. And then you had the same programming model on the back and in the front. So there is a small library which is called Vertex Web Socket something. Forgot. Vertex Eventbus. Yeah, Vertex Eventbus. So you use this, and then you just connect to the Eventbus from JavaScript. So you have the same model. And you basically register a handler for some kind of destination over the Eventbus. And just like you would do in your Java code on the server side, you receive messages. And when you receive messages, you can just here update the interface. Something you need to know is that with this Eventbus object, so it's not just the backend which is pushing events to you on the front end. You can actually publish something. I'm not sure I get the completion correct, but you can say, yeah, you just send. You can also send some event, some destination, and you can pass some JSON if you want to. So it's really handy because you can have the front and the back using the same model of using the Eventbus to pass events around and have some communication. So that's really how it works. We are a few minutes past the hour that was given to us, but Manning said we had time, so I guess we can have a few questions. So if you have a few questions, please drop them in the chat. And there are no stupid questions, so just ask me anything. So there is one person which is late. Don't worry, you're going to be able to get it. Question is, would you mind to repeat what Vertex is? And actually didn't say what Vertex is. So Vertex is a library for writing asynchronous and reactive services applications in Java. So it's a very simple toolkit you can use. You can do all kinds of networked applications, and it's reactive, meaning that you can scale it. So you can scale multiple instances to adapt to some traffic and to deal with failure as well. And it's reactive because you have some bolts and nuts if you want to handle cases where you have failure. So you want to just like we did with chaos engineering, which is something you can catch that in the replay. When you have a service, you make a request to that service. The service is down. There are ways to not be stuck waiting for some response, which is not going to happen. So yeah, reactive it's not just about being asynchronous and scalable. It's also about being able to deal with failures and managing the response time to keep it under control, no matter if you have a system that's working well or if you have failures. Any other question, folks? So there was a question about how much penetration is it having in the market? Is it being used for projects in production? Of course, yeah, we have. So I can't necessarily give names, but if you go to the Vertex website, you will see examples. So Vertex is being used for many kind of services. It's been used in the game industry for backends for games. It's used in lots of enterprises system as a gateway, as a microservice development framework / library. It's used in Internet of Things to aggregate data from various sources. There is one example which you can find on the Michelin blog IT, for example. They are using Vertex for connected tires to collect data and integrate it with all kind of other systems they have. So yeah, Vertex is really general purpose to make distributed systems that are reactive. So yeah, just to close on that, there are lots of users. And at Red Hat, we use it for, so we have Vertex as a project, but we also use it as the foundation, as well, not the foundation, but one of the foundation for Quarkus, which is our other enterprise framework. Is this non-blocking I/O event loop model? Yes, absolutely. If you're familiar with Node.js, there is a small difference. So with Node.js, when you start an instance, you have one event loop for the whole program by default. So you can have workers, etc., but it's not really the same thing. In the case of Vertex, by default, you have multiple event loops based on the number of cores you have on your machine. So yeah, all the asynchronous operations happen on event loops. Somebody's saying, I would mention that Vertex is polyglot. Yes, so the big focus, of course, is Java, but you can use Kotlin, you can use JRuby, you can use Groovy if you want to, you can use Scala. And the good thing is that in all these languages, we have some idiomatic binding to these languages. For example, if you use Scala, you will use not Vertex futures, but you will use the Scala futures. So you can use pattern matching, all this stuff. If you use Kotlin, we have a great integration with the coroutines of Kotlin. If you use Groovy, you have bindings to have some nice DSLs for Groovy, etc., etc. So yeah, I didn't mention it, but the focus is mostly on Java, especially in the book. But you can use Vertex with multiple programming languages on the JVM. I think we have time for just one last question. Who's got a question in the chat? And by the way, there is a code down here. So there is a promo code. It's minus 40% for Manning. So Manning told me it was a permanent code. And I'm not sure, but I think it doesn't just apply on the book. So if you're interested in some other book at Manning, you can use it for to get 30% off some other book. So somebody's asking 450 microservices. Is that a good number? And they are using Hazelcast. Yeah. So you're below 500 instances using Hazelcast. Yeah, I would say it depends what you do. I mean, I can give you a definite answer, but if it works for you, yeah, it's not a number which is shocking. I'm not shocked by 450 instances, so it should be fine, I guess. Then if you're really chatty over the Eventbus and you're just publishing tons of messages to everybody, then yeah, you get some network traffic, but it should not be too hard for on modern system. It's not too big. So yeah, I would say it's good. Probably. If not, then just blame me. All right, so I think it's the end of the session. I'd like to thank you all for coming here. It's actually my first Twitch. So yeah, it's a fun format. If you enjoyed it, just let me know. You can contact me on Twitter. I'm at jponge. So just send me something. Just tell me if you liked it. If you have any feedback, any comments. If you want another Twitch session on something more specific, just let me know and I will see with Manning, or I will do it on my own channel. But if it's related to Vertex, I can schedule something with Manning. So yeah. Thanks everybody. Goodbye. And I'm going to stop the stream. Thank you.